for 15 seconds at uniform acceleration 1.5 and immediately decelerates with uniform acceleration of 5 to rest. How long does the deceleration take? Well, here's what I'm thinking. I'm not thinking this one. Can anybody explain why I'm not allowed to use this one? Doesn't travel at a steady speed. So what we do is we go up, and then am I going down slower or more aggressively? More aggressively. Now, we're going to use my sneaky trick from before. What's the sneaky trick? Ratios. Acceleration to deceleration is 1.5 is to 5. And look, you don't have to do anything fancy. You don't have to break it down anymore. You can just say, look, this one's 1.5 t and this one is 5 t. Is that right? Now, the uniform acceleration is 1.5. Okay, so we'll call that v, and we'll use tan x if you want. So what's tan x, guys? V over, and that in turn equals 1.5. Now, am I lacking a piece of information here? I know the time, don't I? I know that 5t equals 15, so that means t equals 3. Well, that will make this very easy then, won't it? So this is going to be 15 seconds, and what's 1.5 times 3? 15 and 4.5, okay? That's great. How long does deceleration take? We already have it, don't we? What is it? 4.5 seconds, no worries. Now I'm going to sub out the 15t for the 5t for 15. Now what's 15 multiplied by 1.5? Huh? 22.5, no worries. Now, how do we get the distance for the full journey? Area under the graph, which is a half base times height, which will give me what? I have 19.5 as my base, and what about my height? 22.5. So what's a half 19.5 times 22.5? Just tell me what the answer is when you're done. Anybody? $219.37. Yeah, that'll do me. That was pretty quick, wasn't it? Velocity time diagram made mincemeat out of it. Okay, very quick. You can try that later on using UVAST if you want. You'll get the same answer, but you'll just find it takes longer. Okay. All right, let's move on. This one. Ooh, overtaken, and when will it occur? All right. I'm not going to use a velocity time diagram. Can anybody tell me why? Two cars. So, not going to use a velocity time diagram. I'm going to write down UVAST twice. The blue car and the red car, so to speak. Okay? Now, what can we say about the blue car? Starts at acceleration. Okay. Can't say much, can I? Not great. What about the red car? U value? P value? P value? Why is it 20? Has no acceleration. Okay. At what time will overtaking occur and how far from P? All right. S and T. What can we say about the time for both of them? They start at the same time. So the t values are the same in both data sets. So, blue car, red car. Starting off point. Red car flies off into the distance. Blue car slowly follows. Only when the blue car starts going faster than 20 does it start to catch up. Would you agree with that? Eventually they catch up. What is the same in this scenario? The distance traveled is the same at overtaken. So what can we say about S1 and S2? They're the same value, aren't they? Okay. Options. Phi equals U plus AT, anybody? Nope. What about S equals UT plus a half AT squared? I'd say yeah. You have the acceleration. You have the U values. The T value is the same variable for both data sets, and the S values are identical to each other. So I'm reckoning we're going to get a quadratic equation here, right? So let's give it a go. What about the first one? S1, so to speak, is UT, which is 0 times T, a half AT squared, a half times 4 times, and then a half times 4. So S1 is 2T squared. What about S2? 20 times T, then what else? Yeah, I have 0, so then we've lost interest there then. And then S2 is 20T. What can I say about S1 and S2? Equal to each other. Then what happens next? Cancel the T value. That you're cancelling T is equal to 0. Remember, they both start off at the same point. Cancel the T on the right with a T on the left. 2T equals 20. T equals 10. 10 seconds later. How do you find out how far away it is? Insert it back into your distance equation. Either distance equation. And what happens when you sub in 10? 200, exactly. Doesn't matter which one you sub it into. 200 meters away. We all cool with that? Alrighty. The next one, there's a big trick to the next one. I call these interval questions. Okay? An interval question is where you start off at a point and you keep running through different parts. So let's say I start off at point A and I run through point B onto point C. That is an indicator of an interval question, okay? And with interval questions, you never, ever, ever, ever use data sets for in-between points. Do you get what I'm saying? I would never use a data set from B to C or a data set from C to D. Guess what I do instead? I might have an idea. I use a data set from A to B, A to C, and A to D. Why do I do that? It gives me a common starting point for every data set. So one more time, when you're doing interval questions, never, ever, ever start off different data sets for the in-between points. So I'll give you an example now. What's A, B, and C for this question, okay? So here's what we're going to do. Data set from A to B, data set from A to C. Notice I'm not using BC, okay? Does not end well. Okay, what's my U value? Doesn't say, does it? U. What's my U value for AC? The same value. Why is it the same value? Because you're starting off at point A. V value, I don't know. Does it tell me what my acceleration is? Anything on my acceleration? No. Anything on my t value? Oh, sorry. Distance from A to B is 48. Anything for my t value? 4. A to C, guys. What you see here? Anything for my A value? So it's still A. Anything for my S value? 102 plus 48? Oh yeah, 150. Anything for my T value? 10? Because 6 plus 10. Do you see, by combining both data sets together, what did I maintain? I maintained that these have the same variable as each other, and the A's are the same as well. It means I can relate both data sets together. Now, let's find out what we're looking for here. I'm going to try and avoid V, because V is not a good choice, okay? So we're going to use I'm going to use ut plus a half at squared. Okay, just bear with me a minute. Why am I going to use ut plus a half at squared? It uses the S value that I know in both data sets. It uses a common A value and a common U value, and it also uses we know the T values. If I introduce V, do you think your velocity at B is the same as your velocity at C? So these two are different. These two are different values, so we don't want to use any V's here. So anything with V is chucked out the window, okay? So let's do this. 48 equals what, guys? U times 4, a half A times 4 squared. 48 equals 4U plus 8A. 48 equals, oh sorry, divide by 4 and we get 12 equals U plus 2A. Do the same thing for the red set now. And what do we have here? 150 equals U times 10 plus a half A times 10 squared. 150 equals 10U plus 50A. Divide by 10. U plus 5A equals 15. I'm after the A value, not the U value, so what do you think? Just top one take away bottom one, is that okay? Red take away black. Three A equals 27. Oh, sorry. 3 A equals 1 meters per second squared. At home, your homework is going to be 135. Oh, jeez. 135. I did 6, so you're going to do 7, 8, and 10. And we'll take it there on Friday, guys, okay? All right, good class.